Here's a Bitcoin address. 181's POE P5QG Fi2 DMPT FTL5S AMV7 DIVF now. Why does it start with 1? Why are there no zeros, no capital O's, no lowercase l's? Every character you see is the result of deliberate engineering. Bitcoin's encoding was designed to stop humans from losing money to typos. Let's decode exactly how raw cryptographic bytes become the addresses you copy and paste. Start with the basics. Any number can be written in different bases. Decimal uses 10 digits. Hexadecimal uses 16, compressing the same value into fewer characters. Base 64 packs even more using letters, digits, plus, and slash. Higher bases mean shorter strings, and Bitcoin addresses sit in base 58, which compresses binary data efficiently while staying readable. The catch: base 58 isn't encryption. It's a reversible encoding. Anyone can decode it. The point is readability and error resistance, not secrecy. Base 58 is base 64 with 6 characters removed. The digits 0 and capital O look identical in many fonts. Lowercase l and capital I are visually indistinguishable. Plus and slash cause problems in URLs and double-click selection. Strike those 6 out and you get 58 characters that humans can read without confusion. This is the Bitcoin alphabet. If someone reads an address over the phone, they won't accidentally write a 0 where an O belongs because neither character exists in the set. Now the full structure. A Bitcoin address is Base58Check, which wraps 3 pieces: a version byte, a payload, and a 4-byte checksum. The payload is typically a 20-byte hash of a public key. The checksum is computed by running SHA-256 twice on the version plus payload, then taking the first 4 bytes. SHA-256 is a cryptographic hash function that produces a fixed-size fingerprint. If someone mistypes a character, the checksum won't match and the wallet rejects the address before sending funds. That's your typo protection. The version byte determines the leading character. This isn't arbitrary, it's mathematical. Version 0000 encodes to a leading 1, giving us PPKH addresses, pay to public key hash, the classic Bitcoin address. Version 0x05 produces a leading 3, used for P2SH, pay to script hash, which enables multi-sig and complex conditions. Version 0x80 marks a with private key, wallet import format, starting with 5K or L. Testnet uses 0x6F for addresses starting with M or N, and 0xC4 for those starting with 2. 1 byte at the front controls the entire prefix, so addresses are packaged carefully. But what about the public keys inside them? There's a similar compression story. An uncompressed public key is 65 bytes, a prefix of 0x04 followed by a 32-byte x coordinate, followed by a 32-byte y coordinate. And that's a point on Bitcoin's elliptic curve, the mathematical object that underlies the signature scheme. 65 bytes per key adds up across billions of transactions. Engineers noticed we can do better by exploiting the curve's geometry. Here's the key insight. Bitcoin's curve follows the equation y squared equals x cubed plus 7. This curve is symmetric about the x-axis. For any valid x coordinate, there are exactly 2 possible y values, one even and one odd, in finite field arithmetic, which is simply integer math performed modulo a large prime. If you know x, you can solve for y, but you get 2 answers. You only need 1 extra bit to distinguish them. Parity, whether y is even or odd, is that bit. Compressed public keys, I store just the x coordinate plus a parity indicator. Prefix 0x02 means y is even. Prefix 0x03 means y is odd. Total size, 33 bytes instead of 65. The math is identical. The underlying point on the curve hasn't changed. Anyone receiving a compressed key can recompute y from x using the curve equation and the parity bit. Compressed keys are not a different key. They're a different encoding of the same cryptographic object. Here's the catch that trips people up. The address is derived by hashing the public key bytes. Compressed and uncompressed encodings are different byte strings, so they produce different hashes and therefore different addresses. One private key generates two valid addresses depending on which encoding you use. Funds sent to one address cannot be spent from the other without knowing the correct encoding. This is why with private keys carry a compression flag. Wallets need to know which address family to scan when recovering funds. Let's return to where we started. 1A1ZP1EP5QGEFI2DMPTFTL5SESA-MV7-NA. The leading one came from a version byte of 0x00. The absence of zeros and capital O's came from Base58's curated alphabet. The 4 trading bytes before encoding were a double SHA-256 checksum guarding against typos, and the 20-byte hash inside was computed from a public key that might itself be a compressed point, storing just an X coordinate and a parity bit. Every character in a Bitcoin address has a story, small engineering decisions compounding across a global system.